Can we see a screen? Yes, they're safe. They're still awake. They are there. Don't worry. Now, so this is all about cryptography.
Yes.
Something I don't know a lot about, so I'm very interested to hear. I hope you can tell us all about it.
Okay. Hi, everyone. My name is Sherif Abdelhamid. I'm an assistant professor at Virginia Military Institute, Computer and Information Science Department. And this work is done in with collaboration with Professor Sarah Patterson and Blaine Patterson from Applied Mathematics Department. So my work is enhancing cryptography education using visual programming. So first, cryptography is the science of concealing or hiding data or information sent from one person to another or from an application to another application. And the goal is that to hide sensitive information and data from anyone except only the intended recipients. Cryptography is an old science, and it's like date back to hundreds of years ago. However, recently in the last maybe 20 years, with the emergence of internet shopping, online payments, Facebook, Twitter, we are sending sensitive information more than before. We are sharing important data more than before. We are doing payments. We share our medical records, send that. So very important data than before are sent and received over internet. And so there is a need more to protect this data. The problem is hackers are getting more skills than before. If you look at the damage or price tag attached to data breaches in the last years, you can see the United States has around 7.9 million in 2018 in damages. Canada around 4 million, Germany, France, UK, Italy. So a lot of money is lost or cost due to security breaches. Also, we see here that per day around 16 billion cyber crime take place. So the solution is, even if we have the best hardware and software, this is not enough. We need to work at introducing the science of cryptography to younger generations. And that's also not enough. We need to make it more engaging, more straightforward. There is a misconception that cryptography should be introduced at college level or graduate level. We can still introduce cryptography at first-year students or even to high school or middle school students. The challenges we have is that in order to master cryptography or data encryption, the student need to acquire different skills in mathematics, information theory, and software programming. And not only just be good in programming, you need to receive formal training in software engineering, testing, and you need to write a code or softwares that handle big data. And so these requirements act like a barrier for students and scientists, not only computer scientists or students in computer science major, but also domain scientists or students from other majors. So in order to have a better understanding of the current research, we looked at what others have done. So our methodology was first to explore related work. And based on the findings, we design and implement our tool we call VizLab. And then we tested it and integrated within cryptography and computer science course. To explore the related work, we done two concurrent processes. First is to do a qualitative literature review approach, where we went into in-depth and we read what others have done in relevant publications and journals, papers, and was around maybe 30 publications. And this was a very in-depth, in-detailed literature review. However, because this is done manually, it is hard to cover all publications. It's hard to get the global overview. So at the same time, we done a quantitative bibliographic analysis where we gathered thousands of publications relevant to cryptography to understand the general themes and trends and patterns related to the cryptography area. And we combined the findings from the two qualitative literature review and the quantitative bibliographic analysis to fit into our design and implementation of the tool. From the output from the qualitative literature review, and we found that in cryptography education, researchers focus on different directions. First, some researchers try to focus on how we integrate security concepts into existing computer science curriculum. Some others focus on how to create a dedicated course for cryptography. Some researchers focus on how we use active learning to engage students in learning cryptography, how to use real-world scenarios. Some other researchers used illustrations, animations, and visualizations. Even some researchers use chatbots to engage students in learning cryptography. This is what we found from the literature review. On the same time, we did a concurrent bibliographic analysis. So what we did here is that we collected around 10K publications from an online publication database, Crossref. We extracted the key terms from the abstract and title of each paper. And we found around 468 keywords. These are the most frequent terms. And based on the co-occurrences of these terms, if they appeared in the same title or abstract, we constructed something called the co-occurrence network, consists of around 15K edges and links. Each node represents a key term. Each edge represents that these two terms appeared in the same title or abstract. And this is how the network looks like. So you can see that the bibliographic analysis is not replacing the literature review, it's complementing it. But instead of having in-depth, in-detailed inspection of around 30 publications, we have this global view of the research landscape related to cryptography. We found different clusters of keywords. A cluster here means that these keywords or terms, they tend to have edges or links with a density within the cluster, more a density outside the cluster. We colored each cluster or group of keywords with a different color. So here the purple consists of keywords related to students, courses, teaching, and cryptography education. And this is where our research resides, in this cluster. We found other trends or patterns, like here, research related to cryptography hardware, FPGA, energy consumption. Here, research related to elliptic curve cryptography, wireless sensor networks. This cluster related to cloud computing, how to manage big data. This related to digital watermarks and steganography. This topic or cluster related to Chow series, Chow cryptography. And this yellow cluster is related to quantum physics, quantum cryptography. So when we did the bibliographic analysis, it's like we zoomed out. It's like looking at the Earth from the space. And we found that our work is in this region, is in this cluster. And as you can see, the amount of research is proportional to the amount of keywords and the size of the cluster. So compared to other areas, still little than other research areas in the terms of amount of research. So the outcomes. What we found from the related work inspection is that few studies consider programming challenges. People are concerned about how we explain complex concepts in cryptography, how to better explain an algorithm, an existing algorithm to student. But still there is a challenge for students how they translate this algorithm into a running program or a software or a tool that do actual encryption. And as a response, we are working on the specific part of coding or the implementation of encryption algorithm or cryptography. And so what we did is that instead of students getting stuck with implementing and writing codes using any programming language, they just use block-based programming language so that students are not distracted with learning programming or programming. They just focus on the algorithm itself or the problem-solving part. In addition to this, we added another level where you, as a student, not only you do the algorithm or write the codes that do encryption, but you share it with others in a collaborative way. So different students, a couple of students can work on the same code at the same time simultaneously. And this is the design of our system. So it is a multi-tier or multi-layer system. This is the client part, the web interface. This is the server part. And this is the database part that hosts the blocks and the codes. This is the learning analytics component that collect data about the students' interactions with the system. So it can give us insights about the students' performance and how they collaborate. Also, our system is connected to external services like Amazon Web Services, Google Cloud, and also our system can be integrated with existing learning management system like Canvas or Moodle. So now I'm going to share you some screenshots of the web interface. So this is an example of a block-based code created by one of the students. Students on the left side, they can pick any block and drag and drop it to the area in the middle so they can construct the code for data encryption. And at real time, while you are constructing the algorithm using just the blocks, the code is generated in the box at the bottom. Another thing we added here is the menu on the right. So you can click on save blocks, so it saves your code. You can also click on this icon to share it with your friends or your peers, or you can share it with your instructor. And you can click on this icon to submit this code as like your solution for a homework assignment to your instructor or professor. You can construct the code. So for example, this code do a Caesar cipher encryption. And another level of usability we added is that you don't even have to create the blocks, the algorithms from scratch. You can use our existing library called Cryptography. So you click here and it shows you a list of algorithms. You can just click here, drag and drop, provide the input text, and it will produce the output text. And so it make it easier, more usable for students to learn cryptography without being worried about the programming part and have to learn about programming and coding in more depth way. So at the end, our conclusion is that we presented VizLab, a web-based learning tool that is available online for anyone. And it helps students avoid the programming challenges during cryptography implementation. And it promotes collaborative learning by sharing the code with other students and co-constructing the same code. Our future work is to integrate VizLab with existing courses at the undergraduate level. In addition, we are now working on collecting and analyzing data about the students' perception of the new tool, their conceptual understanding, and this will be done using surveys and more class observation. And thanks so much, and I'll be more than happy to answer your questions.
Thank you.
If I have more time, I can show you a demo of the system if you need.
You've got a couple of minutes there if you want to.
Okay, so I'll stop sharing and I'll share the other screen. So this is the system. Can you see it?
Yeah, we can see your.
So if you click on VizLab, this is the tool. You can click on one of the codes in blocks you have constructed before here. And you can run the code and it shows the output here. And any change you make to the code at real time, like here, if I change the word to FOE conference, you will see that it is changing in real time here.
Oh,
and this is.
I've covered that bit of text. I'll move your picture over so we can see it, Sherif. There we go.
I'm sorry?
Can you see it? The picture was covering the text, but we can see now.
Okay. And this is an example of another algorithm. And you can run here the code. If I change the message here, welcome. Can you see here?
Yes, we can see that.
It's changing at real time. Welcome to FOE conference. So while you are constructing the blocks in a very easy way, our system is generating the Python code for you. So you don't have to worry about the programming part. And this is the encryption. You click here to share it with, to submit this as homework to your instructor, or you can click on this icon to share it with other friends. So you click here, add team members, say David, James, and then add him. So David now can see this code and collaborate with you in real time. So I'm going to stop sharing now, and I'll be more than happy to answer your questions.
Awesome. Thanks, man.